Okay, everybody, let's have a quick look here at 4J. This is the final question here that requires factoring. Now, a couple things going on here. Notice, first of all, that I've got a common x plus 3 and a common x plus 3 here. The temptation might be to cancel those two because they're common to both sides here, but I would caution you against doing that because what happens here is there is a factor here, okay, that could possibly be going to 0 when I try to solve this. And if, in fact, it is going to 0, if I try to divide those out, I would be dividing by 0, and I'm not allowed to do that. So this is a quadratic here. What I expect you to do here would be to multiply this all out. Okay, multiply this all out first. I think that's going to be the most straightforward way to do this. Okay, so multiply that out here. We're going to get 2x squared. What's it going to be? Plus 6x minus 5, so plus x minus 15. And then here, this is these are difference of squares. So together, ignoring the 2, that is going to end up giving me x squared minus 9, but put the 2 in there, so 2x squared minus 18. And you see, when we do this right here, now take a look. The 2x squareds, if I try to bring everything over to one side to solve the quadratic, the gift that I get here is that the x squared terms go away. So all I'm left with here is x, bring the 15 over, and I'm going to get negative 18 plus 15, x is equal to x is equal to negative 3. Okay, now just think about that. That is coming from that factor right there. If you had divided those out, you actually would have lost that term. You would have gotten an expression that has no solution. And so there we go. Now again, this didn't require factoring. This is actually requiring the opposite here, okay? In order for me to understand what's going on here, I needed to expand this out and then try to factor the remaining quadratic once I got it. And then in this case, it just became a linear.